Hello, everyone, and thank you so much for taking the time to join me today. We're here to talk about something that I believe is fundamentally broken about the internet today, and more importantly, how we can fix it. I'm deeply passionate about making the web truly accessible for everyone. Today, we're going to explore voice first web accessibility, and specifically how we can move beyond the limitations of traditional screen readers by standardizing embeddable voice agents. Just to give you a very quick introduction on who is speaking with you today, I'm Bryan Vuong, the CTO at InnoSearch AI. Our entire mission as a company is bridging the massive gap between highly visual web interfaces and non-visual access. My background is deeply rooted in this intersection of emerging tech and user experience. I received my PhD in computer science at UW-Madison, and since then, I've had the privilege of leading engineering and product teams at places like Google, Meta, and Walmart e-commerce. Operating at that massive scale taught me two very important lessons. First, the web is an incredibly powerful tool for human independence. But second, millions of people are still being completely left behind by our current accessibility standards. Let's take a hard look at that gap. What is the actual problem we're trying to solve here? For decades, the gold standard for blind or low vision users has been the traditional screen reader, tools you might be familiar with, like JAWS or NVDA. And while they are absolutely essential and have paved the way for digital accessibility, they have two massive drawbacks in the modern web era. First is the steep learning curve. Screen readers rely on a really complex, memorized vocabulary of keyboard shortcuts to jump between headings, landmarks, and links. For a highly tech-savvy user, it becomes muscle memory, but for an elderly user, someone newly adjusting to vision loss, or someone with cognitive or motor impairments, it's a huge, often insurmountable barrier to entry. Second is the severe lack of context. Modern websites are incredibly complex, dynamic applications, but screen readers parse the code sequentially, line by line. They are terrible at conveying the big picture. Imagine trying to understand a complex dashboard or a dynamic shopping cart by looking at it through a tiny straw, reading just one word at a time. Users are forced to carry a massive cognitive load, mentally piecing together fragmented bits of information just to figure out what a website is actually about. This brings us to our solution. Introducing CoBrowse AI. Instead of forcing the user to learn a complex machine language to navigate the web, we asked a fundamentally different question. What if we let the user just talk? What if the computer understood them instead of them having to understand the computer? We are layering intelligent, conversational voice interaction directly over the existing visual web. Let's look at how this actually works under the hood, because the architecture is really what makes this scalable. Our core philosophy was that website owners and developers shouldn't have to completely rewrite their entire code base to support this. That's a losing battle. So, our platform is built on three pillars. First, it's an embeddable JS snippet. It's a super lightweight, asynchronous agent that injects right into the DOM, creating what we call a voice layer without slowing down the page. Second is LLM reasoning. We use large language models in real time to actually read and comprehend the HTML structure. The LLM isn't just reading text, it understands the semantic context, the visual layout, and what elements are meant to be interactive. And finally, the voice interface. We use incredibly fast speech to text to capture the user's natural intent, process it through our reasoning engine, and use natural text to speech to talk back to them, creating a seamless, human-like conversation. Let's talk about what this looks like in practice, starting with intelligent navigation. Normally, a user using a screen reader might have to tab through 50 different navigation links, skip to main content, and bypass pop-ups just to find what they want. With CoBrowse, they land on the page and just say, "Take me to the enterprise pricing page." The agent understands that human intent, finds the correct path in the DOM tree, and executes the navigation autonomously. It also does what we call smart summarization. Imagine landing on a cluttered news site or a busy e-commerce portal. CoBrowse can instantly give you a TLDR of the page. It highlights the key actions you can actually take and completely filters out all the ads, the boilerplate text, and the navigational clutter that usually bogs down traditional screen readers. It tells you what matters. We take this a step further with contextual Q and A and search. Users don't just want to navigate, they want answers. They can ask highly specific questions. For example, does this specific laptop have a 2-year warranty? The AI will scan the entire DOM, find that tiny detail buried deep inside a collapsed accordion menu, and simply speak the answer back to the user. It also handles semantic search beautifully. If a user says, "Show me the cheap options," it knows to correlate that vague intent with the price data on the page and sort or filter accordingly. And critically, it uses vision language models to describe images, graphs, and charts. If a developer forgot to add alt text to a crucial product image, CoBrowse fixes that broken accessibility on the fly by actually looking at the image and describing it to the user. Now, we get to what is arguably the most powerful and life-changing feature: action and automation. Forms are universally terrible for accessibility. Think about multi-step checkouts, complex date pickers, or medical intake forms. With CoBrowse, a user can simply say, "Fill out this checkout form for me using my standard shipping info." The agent takes the user's spoken information, maps it intelligently to the correct HTML input fields, handles any annoying validation errors, like telling the user, "Hey, it needs your zip code," and submits the form. We are turning incredibly complex, frustrating transactions into simple, natural conversations. But I want to address the elephant in the room. To make this work universally, to truly scale this across the internet, we need to bridge a massive gap in web standards. Right now, the DOM is missing critical links. Current accessibility standards, like ARIA attributes, are fantastic for what they do, but they were built for linear screen readers, not intelligent AI agents. They describe structure, but often lack intent. We are calling for the industry to adopt new semantic hooks, specifically for AI. We need agent-readable attributes, standardized tags that explicitly tell an LLM the broader purpose of a web section. We need standardized action hooks, so these voice agents can trigger complex JavaScript events safely without relying on brittle click simulations or breaking the page state. And crucially, we need robust privacy protocols that define exactly how third-party DOM injections should behave, ensuring that user data remains 100% secure when interacting with these LLMs. Voice agents aren't just a neat party trick or a flashy new feature. They are the future of universal access. By combining the reasoning power of LLMs with the structure of the DOM, we can finally break down the barriers of visual interfaces. We can make the web accessible to everyone, regardless of their technical ability, cognitive load capacity, or physical limitations. Thank you so much for your time and your attention today. I'd love to open up the floor to any questions you might have, or feel free to reach out to me directly at the email on the screen behind me. Let's work together to build a better, more inclusive web.